In this video, we're going to look at how to find equations of exponential functions, and we'll do a few different examples, but they do kind of end up revolving around the same idea. So in this example, we start with 80 deer introduced into a wildlife refuge, and by 2015, the population have grown to 180. So assuming this is an exponential growth, let's find a formula for this. So what we want to do is we want to use our formula for exponents. Now there were a couple versions of it, but because they didn't give us like any sort of percent, let's use the version that has B. And I'm going to go ahead and call it T instead of X. It really doesn't matter. But we'll use the form that uses what's called the growth factor. Okay, so what we do know is A, the initial amount of deer. So A in this problem is 80. So I know that information. And then, of course, they did give me a second piece of information, and that was that in 2015, the population had grown to 180. So if this started in 2009, 2015 would be 6 years later. So 6 years later, we know that the population ended up being 180 deer. So if I plug in 6 for T, that's going to result in 180. That's how many deer there are. So I'm plugging 6 in for the input and 180 for the output, which is F of T. And now I can solve for B. So by plugging that in, I can go ahead and work this out. Okay, so let's see, 18 divided by 8 is 9/4. And then, because I'm canceling the tens, and then B to the 6. Okay, and then to get rid of B to the 6, we're going to take quote unquote the 6th root. Now, some calculators have the ability to do like an nth root, but the other way of doing this, and the way I kind of tend to like to write this, is rather than write it as a root, I actually like to write it as the exponent raised to the fraction. So I use the fractional exponent version of the radical. So I raise both sides to the 1/6. And most people are comfortable with plugging that into their calculator. In other words, you'd be plugging into the calculator, parentheses, 9 divided by 4, parentheses, and then your exponent button, whatever that looks like. And then parentheses, 1 divided by 6, parentheses equals, or enter. And that's kind of how you end up putting the calculator. You can, of course, look up videos or instructions for your calculator on Google. If you have issues, though, let me know. Reach out to me. I can help you with that. Just take a picture of your calculator. I could tell you how to enter it. Okay, so if you plug this into your calculator, you should end up with B is going to be 1.1447 if we go 4 decimal places. And therefore, our equation, F of T, is going to be 80 times, so that is our factor, 1.447 to the T. Or you could use X. You really don't have to use T. So what we're seeing is, oops, wow, that's a terrible line. What we're seeing is if we were thinking of this as a rate, and we know that B is 1 plus R, our rate of increase each year is about 14%, or about 14.5%. The deer are growing at a rate of about 14.5% each year. But there you go. That's the equation that we can use. Let's find a formula for exponential function passing through these 2 points. So -2 to the 6 and 2 to the 1. So this one's just a little bit more straightforward. We're given the information, and we're going to try to find an equation. Now, the problem with this is neither piece of information they gave me is going to give me, here, I'm going to switch to f of x. So switching to x's this time. Neither information is actually going to give me the initial value, A, or the growth factor, B, or the percent of growth, R. Okay, so we're kind of going to have to use the information they gave us to see what that tells us. So let's start by evaluating it at the 2 points. So at the point -2, 6. So I'm going to plug in -2 for x and 6 for y. That's going to give me 6 equals AB to the -2. All right. the second point, 2, 1. If I plug that in, that's going to give me 1 equals AB squared. Okay, so that's the information I'm kind of told here. So here's what we're going to do. What we have here is a situation where we have two equations with two variables. And we have lots of ways of solving two equations with two variables. You might remember from intermediate algebra. For this, we're going to use substitution. In other words, I'm going to take one equation, solve it for one of the variables, and then plug it into the other. All right, so I'm going to use substitution. Now, just because the numbers are kind of gross, I want to actually look at the first equation in particular, the one with the negative exponent. So let's look at that one. So a negative exponent really means it's actually in the denominator, and it's just the b that has the negative exponent, the a does not. And that's kind of nice because then I could clear the fraction, which moves b to the other side. And lo and behold, I have this equation solved for a. So this was the first equation. So I'm going to plug this into the second equation. So into the second equation, then I will get 4a. So the second equation is this right here, 1 equals a times b squared. So I'll get 1 equals, and instead of a, I'm going to put 6b squared in 4a times the b squared that's already there. Okay, so then that gives me 6b to the 4th. And now I can do what I did just a second ago, solve for b by raising both sides to the 1/4 or taking the 4th root, however you want to think about that. And let's see, 1/6 to the 1/4. Let me plug that in my calculator. I did not have this one ready. I'm getting 0.6389. If I go 4 decimals again, 6389. Okay, so that's B. Now I have B, so I can plug that in for A. In fact, I'll plug it in right here. I selected the blue pen and it didn't use it. Woo, there we go. All right, so I'm going to plug that in for A. In fact, if you have it in your calculator, don't hit clear, leave it in your calculator. So A is 6 times b squared. And I just figured out that b is 0.6389. And if you have it in your calculator still, I would take your answer, your decimal, and square it, times it by itself. Or if you have the exponent button, just do squared. And from that, I got 0.482, which now I'm going to times it by 6. And that gave me 2.495. I'm sorry, 2.4495. And there's A. So there we go. There's my equation. F of x equals 2.4495 times 0.6389, 89 to the x. Kind of gross, but there you go. I mean, that's what happens when we're kind of making it work for the information we're told. It's not going to be always very pretty. All right, so let's work from a graph. So from this graph here, what we're going to kind of do is what we just did a second ago. We're going to pull information from the graph, some ordered pairs, and hopefully they'll work out nicely for us. So here we go. I see that at -1, 1 looks like a nice ordered pair, and another one here at 3, 4. So those are the two ordered pairs I'm going to use. Oh, wait, hold on. Look, 1, 2 is even better. Let's do that one. Okay, so here I'm going to use the point -1, 1 and the point, oops, sorry. Let me attach my keyboard for a second. It's upset at me for some reason. And see if I can't get it to not be upset at me. Thank you. Detach. Let's see if that worked. Okay, so let's try again. -1, 1, and now the point 1, 2. Okay, so let's go ahead and find an equation between those 2 points. We'll have to use our same trick again. So f of x equals a b to the x. So we'll plug in the 2 points. So First point, negative 1, 1. I have 1 equals AB to the negative 1. And at the second point, I have at 1, 2. 2 equals AB to the 1. Ooh, hey, that's kind of nice. I like that one. That second equation is pretty nice because, well, I think they're both pretty good. Let's do what we did last time. We're going to stick with what we did last time. We're going to use the first equation, which is kind of gross because it's got the exponent, the negative exponent. So here, I'm going to rewrite this as A over B to the 1, right? And if I multiply both sides by B, I get A equals B. Well, that's kind of nice. So let's plug that in then for A right here in this equation. So that's going to give me 2 times B, or B squared equals 2. And if I raise both sides to the 1/2, or just take the square root because this is a square root situation. Square root of 2 is 1.4142. So 1.4142. That's B. Now, technically, it is plus or minus. There's technically 2 values for B. We are assuming it's a positive. Okay. Now, A happens to be the same thing because A equals B, right? That's what the second equation, I mean, this equation right here says. So A also equals, oops, 1, wow, let me write 1.4142. Okay, so there's our equation. F of X equals 1.412. Oops, I missed a 4. 42 times 1.4142 to the X. Now, because it ended up working out so quickly, they might have actually written their final answer. If you wanted to be kind of cute, you could have just left it as a square root and then wrote that, okay, B is a square root and so is A. Therefore, the final answer could have been written as square root of 2 times square root of 2 to the X, which, I mean, I don't know if that looks all that much better, but that's another way of writing the answer. The decimals, though, are fine for moms, so you can go ahead and stick with the decimals for our answer.